My name is Ujjwal. I work as a technical evangelist at Microsoft. I have my colleague Saurav with me. He's also a technical evangelist at Microsoft. So we both have been working on multiple things, especially on IoT these days, and with Azure. Azure is our key focus area. I've been with Microsoft for 9 years and have been working on multiple things, including apps, webs, and Saurav,
And I've been here for about 9 months, so I've been also working on pretty much the same things.
Yep. So we will go ahead and quickly cover a couple of things today. It's an Internet of Things talk. Basically, the talk is about architecting how you will be architecting Internet of Things with Azure, what Azure provides to you or enable you to accomplish very, very quickly. So we have some good demos. We'll go and start with a quick demo which we built for a hack, internal hack, which we did internally at Microsoft. It was a global hack. Let's start with the demo. So this is a device called ManiBot, which we have created. I'm not sure. Can you focus the camera there quickly? So that device is a home monitoring system device, okay, which has an infrared sensor with a camera attached. And let's start with the demo then, Saurav.
And first of all,
so it takes, the camera is attached to it, but it doesn't capture the camera, or its camera is not on all the time. So you just see my picture coming up, right? So what happens is,
so this is a motion sensor right now. The motion sensor, we right now set it to every 5 seconds. You can just come inside the motion within the motion sensor. If it detects the motion, what it does is, I have a camera, like right now using the laptop camera, and it clicks the photo, and these photos are getting posted to Azure Live in the blob storage, and directly we can fetch it from there and show it in a simple browser. Now think of this as an home intrusion detection system. For example, you're out for a long time and you want to see whoever person comes on your door. Immediately, if there is some motion you want to detect, or probably for an hour you have a kid at home and you want to detect what all is happening outside. So this is just one of the scenarios where you capture the motion sensor. As soon as it detects, it's taking a photograph. The other thing here would be, for example, consider with the distance. Right now, it's just detecting a motion, but say you have a camera set up at the top of your door and some person is trying to enter the door. Now here, it can be an intrusion detection, probably a thief or something, because here, as soon as the distance of that person from this sensor reduces to say about 50 centimeters or 60 centimeters, you want to directly make a phone call. You want to directly make a phone call or a video call to a predefined user. In this case, it will be the house owner, and the video will directly be initiated just because the distance between that person and this door reduced to a minimum. So we'll try this as well. You think is on?
Yep.
This should be between 30 and 50.
Yep. So just need to reconfigure this. By default, it's going to be configured. It goes with video call. So start with my other machine. I have a link
30 and 50,
device connected on this machine. So we'll probably need to switch. This will start with a video call, right? It started, motion detected.
No, it's 29. Just tell me when it's between 30 and 50.
So it says motion ended. Again, you can see all the data. We are just keeping track of the data, right? All of this is being pushed as well. So if you want to keep track of how things are happening, and we are going to talk about this through this session, how you are capturing millions of data per second. Is there a way to do that? Yes, we have. We will talk about that as well. This detected?
Yep.
Right?
Yep.
Motion detected, and I think it started. So it should give me a call on link if demogods are with us today. So, all right. So let's see. What happens is, in this case, it will give us a call on my link device, which is on a separate machine. So as Saurav mentioned earlier, you can carry the device as wherever you are. Like it could be a phone, and not necessarily a Windows phone, right? It could be Android phone, it could be iOS phone, iPhone, right, for that matter, or any tablet for that matter. It will go ahead and sync that, give you a specific call. The other thing is, of course, network is important for this solution. You need to have a good bandwidth and good network, which will help you connect and call. So while this goes on, I just wanted to also talk about the different things which we will be focusing on. So we will be talking about different sensors which is available. what sensors we have chosen for certain projects. There are 3 architecture solutions which you're going to project through today, especially on the IoT side of things. First one was home intrusion system. It's done. So you can see the call coming in. So this is Saurav's machine. It's giving me a call. Now I'll be just going to switch to this device. Can you switch to first one?
It's come. Yeah.
It's come. It has come, right? Okay, this is my machine.
Project.
I have to just project it. And you will see a link call coming on my phone. So you can see this, right? Just phone got disconnected, I guess. Right? But this happens. This works perfectly fine, right? So let's switch back to the third device again. Back to your device. Okay. So the way we have done is we have taken this sensor connecting to the cloud. So do you want to explain this? The good thing is, this is something which we have won as an award as well, internal hack, which was done in 2 days' time. And, Microsoft India, we represent Microsoft India. Globally, we were amongst the top 3. Right?
So overall, not only link, it's right now configured with Skype as well. You enter your live ID, and but there, in the case which is configured right now, it will be a voice call, not a video call. The video call will take place only with the link. So simply, I have a Bluetooth module connected right there. This is connected to my Bluetooth. I have a motion detection sensor through which my photos are getting captured as soon as the motion is detected, and a simple ultrasonic sensor which just calls up the other person whom I've configured already, and that is a call is made to that other person. A very simple scenario, a very basic IoT scenario, powered by Azure in the backend, because the blobs are currently being stored at the backend. Then we can easily create a service which will capture all those images at the blob and display only the recent ones, to display it, say, for example, to the homeowner.
So take away the device. No, device is. Sorry?
Device is installed at the door, right?
Door, yes. Tamper the device.
So
Right.
So the tampers, he has to come near to the sensor.
As soon as he comes near to the,
so that is what we have captured. As soon as he comes near, the video call is being made. And even the motion sensing is done. Even the photos will be sent to the cloud, and you can easily put an alert there whenever a new photo is uploaded. You get a SMS on your phone that this is what's happening. And through that, as soon as the person enters within the 30 centimeter range, the video call is made to that person directly.
Can you make a VoIP call?
Sorry?
VoIP call?
VoIP call. Or voice over IP, right?
I don't have a link. Assume that the mobile is not supported for video call. As a call center people, I would like to inform them, because call center have a...
We can work it out. So there are multiple ways. On Azure, yes, on Azure we have something called Twilio, third-party provider, whom we can integrate with our code, right? So that can enable us for SMS or a phone call. Yes, cool. So I'll quickly go ahead and talk about, I'm sure you know all about Internet of Things in terms of what exactly it is. The definition is out there. Multiple devices connected together on public network or private network or hybrid kind of scenario. One important thing, the focus has shifted from apps to IoT for last 1 year, and some of the studies which shows that it's about 1.7 trillion of worth of business which is going to be there out by next 1 year or 2 years down the line.
And this is an interesting slide. These were the predictions made some time earlier, that with the number of devices coming in into the IoT, starting with 50, 75, 75 and then 212.
So
and all of them are predicted for 2020. So day by day, even the predictions are increasing, and it's increased, say, 50 to 212 right now. So 4 times.
Yep. So it's definitely a good time. So there are different segments which we talked about. Home intrusion is one. Home detection is one scenario. There are multiple other scenarios like smart cars. We have another good demo which I will be projecting through today in our session.
We have the team ready for that.
We have the team ready for that. And then there are other scenarios. For example, smart cities, the initiatives which have started with the Indian government, right? The entertainment, logistics. There's so many other scenarios where IoT plays a huge role or has a potential to play a huge role. And, we will be talking through how simple it is to architect your IoT-based solutions with Azure, okay? And then also implement it, right? So, quickly, from the taxonomy perspective, I just wanted to bring forth that we divide into 4 segments. Large would be something like a ATM machine itself. A mobile devices or something which can be mobile would be a handheld device, right? And then we also have something like a small device which could be with the boards which we have or the sensors we have, and then a microcontrol, micro sensors or actuators based device would be falling into micro one, right? Now, to program this, when we were outside, there are a lot of questions around, how you program it, like the multiple options. And with Azure, you get a choice of languages to choose from. Like you basically have, or you can continue to choose, in fact, C++, Java for that matter, or Linux as a platform if you want to choose, Node.js for that matter, anything and everything which you would want to, you can continue to use and build IoT-based devices with Azure. So, including, so when I talked about it, I also wanted to bring forth the Azure part. So, from monitoring to management, right? And we will be like content distribution. All of this part will be coming from the cloud side. So, we'll be quickly showing that through this.
So overall, this is the platform from Microsoft and IoT in general. We start with the devices and assets. We capture data from the sensors. Then we send it to the cloud and infrastructure, where we will start doing data analytics with whatever data we have received. And concluding with the insights from the data, you can have application insights, you can have any insights based on you want. Even on mobile apps, you can show the insights. And it's simply, the project can be quickly complex, but the overall architecture is divided into 4 blocks. So we'll be explaining them one block by one, and we'll start with devices and assets.
Cool. So if you look at this diagram, this is one of the basic abstract level diagram for architecture. So you have 2 set of devices, right? One devices which is IP capable, which can directly connect to internet. Another set of devices or sensors which cannot connect directly. You probably would need something to connect through a gateway to the cloud, right? And then in the cloud itself, you can write, like you can have custom cloud service code, which is custom code out there. And then the different platform services which is available from the cloud platform itself, which is Azure. So like data analytics or storage for that matter, or some kind of compute or some machine learning. All that is available, so which will be changing across as or adapting depending on our requirement. And then the third-party services, the gentleman asked about making call, right? So Twilio services is one which allows us to make calls or or send SMSs. Then we have other third-party services which you can also integrate, like Link, Skype for business, which is enterprise services, right? So this is a small abstract level thing. And in abstract level scenarios, usually the custom code would be written for a website, virtual machine, a worker role, or a different type of cloud services doing compute. From the cloud platform services perspective, we talked about HD Insight is for big data analytics, right? Databases which is available, service bus, which is very, very critical. I'll talk about, like we will be talking about service bus in much more detail today. It's one tool which is available or a platform which is available in Azure to sync your data, get data and work on it. So we have multiple services in Azure. One very interesting thing, we have Azure Night to Night, which is a full night of hack, not exactly hack, but I would say a lot of features showcasing demos right throughout the night, where we'll be talking about different features. Services is one of them, wherein you have multiple things to fetch, work on it, save to database, get back to notify to users, right? So that's one platform. When we look at the IoT cloud gateway kind of scenario, what we do is we converge all of these together and put in the cloud gateway itself, right? So we can write code from devices directly, which was Manibot for that matter example. We have scenarios where in pattern 2 we connect to a virtual a custom role, a cloud machine role and virtual machine role, and then connect to service bus, which is kind of similar to the next or the other demo which I'm going to present through. Okay, this is what home intrusion detection scenario architecture looks like. So you have different types of sensors, right, connected to the cloud, wherein we are also integrating. So this, imagine the scenario, right? Every day I'm getting data, every day, and you can't control people coming to your house or flat, right? You will have people like coming from postman, a courier guy to somebody who delivers some food item or household activity, right? Or in general, your neighbors will also come, and this also because it will be posted across on the top, right? So you will also detect neighbor coming in. How do you identify, which is the right data to be sent across, or which is the right data, even if you received it, which is the right data to actually work on, right? So for that, you need to have some kind of intelligence which machine learning provides to you, and then we can view that in different devices, which is your smart devices, a phone, tablet, or desktop itself. So home detection system, we did this.
I have one question.
Yep.
So you mentioned that the sensor or camera will capture the photos, but then how do you push it to cloud? Is it 3G or some Wi-Fi dependency is there? How do you push it?
Great. So that's a very good question. So when we talk about IoT, right, we talk about we didn't even discuss much in detail, but we talked about some sensors. We talked about the cloud part. We mentioned storage, but we didn't mention connectivity yet, right? So connectivity plays a very, very important role here. You need to have either, so you need to think through 2G, 3G, 4G. Then there are other scenarios, which is Wi-Fi. So apart from GSM, you have Wi-Fi. And very interestingly, we have a good demo today. We will be showcasing there are other network protocols, which are, for example, a real-time car network scenario is what we're going to present. And there we have a very interesting other set of sensors which is available. So yeah, that plays a very important role. So 4 things when we think through IoT, we have to think of these 4 most important part. Okay.
Zigbee.
Yeah, we'll talk about it. Sorry? MQTT.
How it is, I think that MQTT is for IoT, means that it is
Yes.
now how this Azure is replacing that MQTT, or it is using a similar kind of architecture for that?
Not really. So multiple protocols are there. We support all of them. So basically anything which has REST-based architecture is available, and we support that. Okay.
Say that MQTT is similar to the service bus, we can call it as the MQTT.
Not really. See, we can. It's not. Service bus is quite similar. It has a messaging system. You have a queue. You have a messaging system. You have a topic and relay. Basically, you do a queuing and messaging according to the requirement. So it's quite similar, I would say. I can take it offline for the interest of time. Through HTTP, you are connecting to the gateway. From gateway, you take it up with the service bus, and then take it further, like for storage, or you can add machine learning, do analytics on top of it, then send the data back. Yes. Yeah, absolutely, we can do communication over TCP/IP. Yes. So, very interesting. So another scenario. So this is a scenario which our colleague from Europe built. And imagine, like, if I stay, let's say, I'm actually staying in Bangalore, and it rains a lot over time. And Saurav is from Delhi, and even though he stays in Delhi, Bangalore, he goes home, goes for vacation sometimes. What happens? We have small garden area, okay, and what happens is when we go out, we either see, this is not our backyard though; it's our colleague from Europe who has this kind of backyard. But then, what has happened in his scenario as well is, at times when he went out for vacation in a rainy season, it was completely dampy area, like with a lot of water, and at times it was also desert. So because the water was not there, and so the solution is this is a home sprinkler system solution, which is automated process, nothing required from a human intervention perspective, and you get to see all kind of data on your device wherever you are. So we basically added a couple of sensors here. One sensor is for humidity. This is an Oregon sensor which is available for identifying the humidity of the soil. It's a scientific sensor which is available. It's a publicly available sensor. Few boards. Now there is a difference between microprocessor and microcontroller, right? And of course, depending on the scenario we choose to use, and of course you need to optimize the solution as well. So everywhere, if you start using processors, that will add to your whole solution. So what we need to do is optimize. So in this case, some controller is required. We use Atmel Atmega board, a small one, Arduino 328 board. For having a hub kind of system, here we use something called Neutrino board. It's an open source board with the .NET micro framework on it. Okay, so in this case, you can code with .NET micro framework. It's very similar to my .NET technology. You also have a GC built into it, and you can write code in C# kind of language, like basically C#. Absolutely,
Yeah.
absolutely. Raspberry Pi, in fact, we have a very good tie-up, with them now, and we support Windows 10 is going to be available with Raspberry Pi 2. Yep. So quickly in this case scenario, so these are some of the sensors. That device, Arduino device, is actually the hub device, which has also a GSM module, which sends 2G data, data over the 2G network. And this is a tap which you use to actually, turn it on so that the water can go depending on the soil humidity, right, and moisture. And then, this was coded with Visual Studio using .NET micro framework. Very simple. Again, in this case, we also need to, humidity and moisture also needs to be judged from your environment, like example, the atmosphere around it, right? So there are some sensors which is again the same oregano sensor allows us to do that. You need to have some kind of fan associated with that. A simple motor can help you create that. What we did is, created a own wind and rain sensor using that motor, right? Small prototype, coded with Visual Studio, and the same kind of scenario. So we connected with GSM to the cloud, right? With REST-based architecture. In this case, it's a simple HTTP REST protocol which we use, okay, to connect to the cloud.
Now, once we have the data, the posting to the cloud is one of the ways to do is through Azure Mobile Services. So Azure Mobile Services, if you want to send some information on the cloud, if you can see on the screen, there is something called sensor ID, channel, average speed. It's a post to the Azure Mobile Service, and what you receive from the server is all the details stored in the database. Azure Mobile Service itself provides you a method to store data, which will obviously connect to the backend SQL database. But immediately once you send your Azure Mobile Service application key and your name to your code, it's posted to the server, and the ID is auto-generated from the server, which is received from the server, and it's just written at the end, the ID which is received. So once we have that, this is all the header information, what is the content length, content type, and this is just a simple insertion of a record in the table in an Azure Mobile Service.
So Azure Mobile Service, as Saurabh rightly mentioned, is a backend service provided by Azure. Okay, so you don't have to write anything on top of it, you just have to use it. It's a connected backend service which connects all the or most of the services on cloud with each other.
And that includes even your push notifications to configure across all the 3 platforms.
Right. Yeah.
Just want to know what is the kind of security that Azure is going to give us in terms of mobile services when I am getting the response from the cloud?
Absolutely, very good question. In fact, we will be talking about that next in a few minutes. So security is a top concern. Security, privacy is top concern for Microsoft, and we have implemented that as much as possible on Azure. Okay, there are a lot of things. One, of course, the single login log of password is there. We have added multi-factor authentication. So basically, which means you either receive a phone call or an email. Apart from that, you have to add that code to it on top of it to make it access. On top of it, we have Active Directory system also integrated on top of it, right? So if you are looking at enterprise kind of scenario, you can have your Active Directory activated, and based on role, you can provide control on top of it. We have some good demos. We have a talk around mobile services next, I think after lunch. So more details, or we can take it offline, just in interest of time.
Yeah. And this is the part.
This is the part you're talking about. Apart from that, we also make sure that firewall access is firewall is provided, right? So if I am coding from some location, I need to enable that IP address on the cloud so that that is accessible. If I am again trying to change some kind of code, again I have to have some kind of admin right to enable the IP address in cloud, right? So additionally, we also support single sign-on, which is Google or Facebook or Twitter or Microsoft Account ID. All are supported, right? JSON in this case. JSON data is coming up.
And, yeah, just one more thing we missed.
Yep.
Event sub. So Instead of Azure Mobile Services, we can even use Events Hub. Events Hub is an offering in the service bus where we can ingest millions of events per second, and all of them, it just provides a platform where you ingest the events and it's sent across to the backend where you can do application insights into it. This is another mechanism other than Azure Mobile Services.
So this is something which we have implemented in a very nice project which we'll be talking about. I just don't want to you to skip that. Quickly move through this demo. So you know what we have done is my colleague actually created a website which is also hosted, which is a PaaS service on Azure. It's called Azure Website with all kind of analytics, right? So we get soil info about, we got atmosphere info, when the weather was good, when the weather was not so good, when do you want to turn on the sprinkler, right? What time you turn on the sprinkler. All that information is captured and very nicely represented. Now this data can be also connected to your worksheet. For example, Excel is also, you can directly connect Excel to a database. You can put the credential and use it. And this is the overall architecture, very simple architecture for this. We have this small set of like the sensors, the sprinkler system, which is connected to the mobile services using HTTP REST, and that goes to mobile services, as Saurabh mentioned earlier, directly connects all the backend. So we are already connected to Azure SQL database, and then the website, which is also PaaS service, right? And we are creating different scenarios using. So this website is based on MVC ASP.NET, but you're more than welcome to build with Java or any other programming language, PHP or Python you want to create. You can use that as well. Okay, that, and then that is served across on a browser using HTTP protocol, which means you can access through any device. Yeah. For? Right. Great question. So the question is for devices which are very small, even, right, which doesn't pass the JSON. So we will do a compute on the cloud itself and send the data accordingly. Or you can use the smart devices. So for example, the phone. So in the same case which you have used in our Carnet project, because the device, even though it has capability to compute, people would not have that kind of time. We didn't add a display module to it. So what we did is, we have connected. In fact, we'll talk more about it as we go along. So you can tether it, right, using Bluetooth. So through the cloud, you can have a GSM module attached to those kind of devices, right? And so we'll take it offline. I guess it will be a good thing to talk about it in more detail. But we do support, and if it is not REST supported, how would you communicate otherwise? Right? We'll take it offline. Security we mentioned. So this is the same slide which Saurabh mentioned earlier. The connected devices with the infrastructure, analytics, and insight. Now, good part is very small set of code. Like the mobile services, we just have when we create a mobile service. In fact, we have a session post lunch. In the interest of time, I'm not going to create one, but we will be showing you one which you have created. You get to send the data. This is a Node.js file for the server side script, and you will capture. This is for the SQL query, right? So you are fetching data and then providing info on top of it. What we did was also created a sprinkler system, and this guy, when he comes back this time, he has fruits out there. He created marmalade and all, using this. And good thing is this website is actually working. Do you want to show this quickly?
Yeah.
So
go back.
Just take this website. This is the website, right? Escape. Capture this website, and this is live. So if you want to have a look into this, you can actually go ahead and look at this. So it will give you all the data, analytics, and so on and so forth. This is hosted on Azure. That's why you have not, you can also probably take a domain name and then put a naming, and then it will be a custom name. But right now, just to make sure that it's running on Azure, you can see this arrow says .azurewebsite.net, right? Yep.
What are the analytics platforms that you attached to Azure, which is available for the analysis?
Great question. So what are the other analytics techniques which we have added? So we have something called stream analytics we have not talked about. Stream analytics is very, very interesting. We have been keeping, so throughout the talk we have been mentioning that Events Hub allows you to take millions of data, capture it, and per second. Now this is huge amount of data. How do you actually work on that data, right? So stream analytics is a part of Azure offering which allows you to capture that stream as it comes, write code on top of it, very simple code to fetch the exact amount of data based on your logic, and send the data either to storage or to another analytics system, right? That's one, stream analytics. We have operation insights, another one. Then we have something called machine learning web APIs. Machine learning APIs gives you predictive analysis, right? Additionally, on top of it, we can also connect to HD Insight, or if you are on a Linux based system, Hadoop is available. So either of those, right? So we have 4 different things. Day before yesterday, we have released something called Azure IoT Suite. Okay, so if you just search for, if you use Bing or Google, whatever you use, you can just search for Azure IoT Suite. You'll get all kind of packaged bundle which we offer for Azure with IoT. Okay. Sorry.
Sensors, the compatible sensors, where do we get it? Is there any marketplace or somewhere?
Yeah, there are many actually. We can take it offline of us. Right, service bus allows you to do that. So we have something called topic and relays. Topic is something which is associated to your work of interest, right? So it will allow you to do that. We are running short of time as well. So okay, the website is up now, so you can see this. My Connected House. Just browse on quickly. So we have date, time. You can find it's real time. You will find this data 18/3/2015, right? The right temperature, right sign, everything is coming up right from the Connected House. So quickly wanted to now talk about connected car. In fact, the best thing is to start with a demo. So let's set up the things out here. It's a very interesting project which we have been building. It's in nascent stage right now. It's something which we are we have architected and we are implementing as a demo right now, which will be available soon with this entrepreneur set of students who are actually building. So it's a 4th year set of students who are building with us, and I think while they set up and put it out here, we will explain this to you, right? So
overall, what happens is, consider the taxi aggregation business right now. Earlier, it was a real pain booking a taxi and going through all that stuff. With the launch of Uber, Ola, it's become pretty easy now. What's basically happening is all the things which are getting scattered, they are now becoming managed. Therefore, making it easier for the consumers to consume it and for the businesses to make profits. Similar thing, what we are trying to do is now think of the scenarios where you're driving a car, and it's madness when there's a traffic jam. Now the next thing which you want to get into this is you want some management within that. So CarNet right now is a special project among which multiple things it does is increases safety. How? You have 2 cars going along, and as soon as the distance between the 2 cars reduces to a minimum, a notification is sparked up. So the accident, even if it is a car coming from the back, the accident is sparked up, the driver can take some suitable action. Second, if there is a fog scenario and you are not able to have good visibility, in that case also it detects what is the obstruction distance in front of it, and after it gets reduces to the threshold, again you have a notification spark up. Other than that, we have multiple things like you can have simple advertisement services. Like, for example, if you're going ahead and you're going on the road and say Reliance Fresh is out there, and you want to see what are the latest offers going on, and probably that day you're trying to buy grocery too, and immediately when you're within that area, the app will be integrated with the backend of the Reliance Fresh community. They will send across your updates, giving you offers only if you subscribe to them, because there are some who may not want to do that. And the other thing would be it basically provides a great customer experience, wherein you can do all this stuff with the car. Right now we have the small cars ready with us, a prototype, and in reality it will be a self-driven car which will provide all this stuff.
So do you want to run this? Okay. So let us first run this. I think the video is going to be also projected. Can we project the video on top on the screen? What is the video? Okay. So there's a board with couple of sensors mounted to this car. The actual form is not going to be a car. Actual form is going to be a kit, which is going to be put in a car. Now this car is actually connected to mobile devices. So we have two mobile devices, Android and Android and Windows Phone devices, right? Now these devices, can you just focus on the phone as well? So what we have done is we have simulated the map. So we have taken a calculation of this area, right? And we have also simulated a map. So in real world scenario, it will be sending a GPS data. In this case, we have simulated a map as well. So you can take the camera. So the camera, you can see a map. This car will be moving and sending the GPS data. So you can see the location is moving, right? And what happens is this will be keep on sending the data. As soon as we come along, it will push a notification to the app saying that you have to be alert, like you have to slow down or probably have to avoid accident, right? So this is how it's going to be. It's not even alpha prototype. It's much before that. We just wanted to put this through in the demo part, so that's why. Now we'll be maybe we can talk about. So let me introduce the team first. So we have Abhay Shastri, and then we have Rajiv, we have Nishant, and then Sanjeev. These are fourth year students. We have been working together, I think, for last 3 months, right? 3 months, and so we'll talk about this. I think you got the perspective, right, of what this all device is working with. We have Saurabh mentioned about advertisements. This also has a business value, another business value. So think about a scenario wherein you want to know. So Saurabh mentioned about Reliance Fresh. Think about a scenario. So every day we have to do some kind of shopping, right? Or maybe every week per day at least, right? Grocery or something, household stuff. Now you need to know the best route available. In real world, you will find maps. Maps would be with an app. You will be able to detect which route is good depending on the traffic, right? However, you would not be able to detect, like you will not be getting data, something real-time data, something like a road dug up, which is very often in India, right? You would not be able to find scenarios wherein there is a huge traffic jam at a given point of time in real time, right? This will allow you to do that. Additionally, we also have something like a kit which is available. The same kit can be installed in a traffic area, and that will keep on pushing notification depending on your choice of subscription. For example, you want to do, today is Monday, you want to do a grocery shopping, right? Or maybe so it's Friday, you want to do a grocery shopping. So basically, while you are going close to that traffic network area, it will be pushing data to you depending on the subscription. Now let's start talking about which board, why they have talked. Can we have a mic, please? Hand mic? Do you have a hand mic?
So we'll be asking them some questions.
So I just wanted
whoever
to
comfortable, they can start
wanted to explain through our conversation why we have chosen what, right? So Abhay, which board you have selected?
Basically, we are making use of, am I audible?
I think in this room you are available audible, but
So basically, we are making use of BeagleBone Black. So it's basically okay. So basically, we're making use of BeagleBone Black. It's basically an ARM microprocessor, and it also comes along with two PSU microcontrollers. So you get the functionalities of both. It also comes with 65 input-output pins. So in comparison to this board, like the next alternative which we had was Raspberry Pi. But compared to this, Raspberry Pi is inferior in many aspects. For example, it comes with only like 17 input-output pins, and like this also comes with around 4 GB of internal memory. But Raspberry Pi comes with none. And this has a processing power of like around 1 gigahertz, and Raspberry Pi is around 700 megahertz. So in all aspects, this is much better than Raspberry Pi. So we went ahead with this board.
Excellent.
good. So,
And so after the boards,
BeagleBone.
It's called BeagleBone Black.
BeagleBone Black. You have multiple. So post this. In fact, these guys are also going to. We have an IoT booth. So if you are more interested about knowing this in details, you can come down to the booth area. We will be explaining in much more detail. We will give you all the specification you need. Okay.
so once the booth is done, anyone of you can take this up. Once the booth is done, you guys must have used some sensors. So which all sensors did you use? And
This may go to production market. So consider a real situation where 5 cars will be moving each other and near to each other. So a network has to be formed there. So it should be 100-meter distance. So we have chosen Zigbee. It's it covers 100-meter distance, and a mesh network will be formed. So each and every car will be connected. Local data will be communication will occur through Zigbee, and non-localized data will occur through cloud.
Good. We will take all the questions offline. I'm sorry, we are running very short of time. So I think pass it on. We will take questions offline. Okay. The next part which I wanted to talk about is, we talk about sensors and this thing, right, connectivity. We want to talk about one quick thing about data, right. So the very important thing about data is, advertisement for that matter does not carry a strong, info type, right. It's not very, very important, wherein accident happening is very important. So how did you, what any solution which you had for that?
Okay, just repeat your question.
So the question is, while you created a schema, did you think through some kind of scenario wherein accident type is happening, or
Well, for the entire project, we came up with a schema which involves around 6 tables. So table number 1 will be basically the personal details of the customer, like the person who owns the kit, actually mainly the driver. The second table which we came across was basically a table of the dependents of the driver. So this would contain the maybe the details about his friends or his family members, just in case an accident has been if there is an accident, so an immediate notification will be triggered and that particular person will be contacted automatically. So this is the second table we came across. The third table we came across was an advertisement table. So this basically keeps a track of all the advertisement which has been viewed, or maybe which advertisements to be displayed in which location and stuff like that. And the fourth table which we came across was the table which contains the real-time information of all the vehicles on the road which contains this kit. So through this particular table, we can get to know the real-time location.
So yeah, continue.
Okay. So through this, we can actually get to know the real-time location of the vehicle, as well as what's the current status of it, whether it's working fine or something like that. And the last table which we have is basically a location history table for each and every single kit. So this contains maybe a location history of each vehicle for maybe 10 days. So this can be used for tracking purpose. For example, a vehicle gets stolen or something. So you can go through this data, and you can track the motion of the vehicle throughout the 10 days, and it can be used for further analysis. So these are the tables which we have currently implemented. We are also reviewing the entire process, so we may add up to this.
Right, so you can see here the latitude, longitude data, and some of this are real time as well. So we have been doing experiments on top, so you can see timestamps, which is kind of close to this. But you see the type, column there out there. So that type depends on your high. Sorry?
I'll explain.
Yeah, please go ahead.
Yeah, basically the type here denotes the type of the vehicle. Basically, there are many types. So, for example, one can be the safety type, for example, ambulance or any other paramedic vehicles. Second can be police vehicle or something related to crimes, and the third can be fire trucks and stuff. And also, in the type, we would also want to combine the type of advertisements which the user want to view. So here it's an integer type, so we are considering it as a bit of maybe it has a data type of around 8 bits. So maybe last 3 bits we'll be using for the type of the vehicle, and the first first 5 bits for the type of the advertisement which the user would want to watch.
So this is a site which you're looking at, right? Is the Azure portal, and in this portal we have used different services, including mobile services, SQL services, storage, and service bus. So service bus is where we are connecting. We'll talk about the architecture in a few minutes from now. You have one more question to ask.
One more. Zigbee we talked about earlier, right? But the sensors still remain. So what type of sensors have you used here?
Well, we are making use of a GPS sensor to collect the GPS data. Then we also are making use of Bluetooth. It's not exactly a sensor, but we are making use of Bluetooth, tether it with the mobile device so that it can enable internet sharing with the device. So through this we are able to connect to the cloud. And along with that, we are also planning to implement a GPRS module or a GSM module, so through which we don't require the mobile internet, so we can directly communicate with the cloud even without the access of the internet. And we may make use of sensors like accelerometer, like we are not using it right now, but maybe in the future implementations we may have sensors like accelerometer and magnetometer, which will actually determine the orientation of your vehicle.
So if it has met an accident, it will send a distress signal quickly.
Can we see the mobile app which they are using for?
The app is still in development, but yeah, part of it you can see for sure. We'll show you.
What will the cost of production?
Exactly. So the cost of production is very, very low right now, and the kind of devices, that's why we didn't put a display board, and we're not planning to put a display board separately, because usually while you are driving, we definitely do not want you to deviate from driving, right? So notification comes in with integration of Cortana. We are planning to add voice, which will help you identify or just hear, and you can take action accordingly, not look at it. Advertisement part is something which will only come when you are at a traffic signal where the traffic signal is less than or more than 1 minute, right? So that the time is, because you want to avoid an accident, we don't want you to get into accident. So we have done it that way. So the cost is I think less than 10,000 rupees, right? As of
Yeah,
now.
right now like it's around 8,000 or so.
8,000 because the board itself is BeagleBoard, which is 4.5K based. It's not built in India right now. So once we are into the production mode, this will definitely go around 6K or something.
Like it's actually a
$100.
build board right now. So later on, if we want to get it into a production, we may have to manufacture our own board, which may like be cheaper than the one available right now, because we may not require all the features which are present in the board right now.
Can we switch quickly?
Click on 3.
3, yeah. So I'm going to go ahead and thanks, folks. I mean, if you guys are interested, right, we'll definitely, please come down to the IoT booth and have a look into it. Like this will be there demonstrated. Quickly, I want to talk about the architecture here. So this is something which we have devised, while we're thinking through the whole scenario. Most importantly, you can look at all the components which is available, and the CARNET system, the owner system. Owner is the device owner who will be connecting to the cloud, using this phone device connecting to the phone. This whole part, the middle segment, is where the cloud analytics and data storage part, messaging part is going to happen and is happening right now. This part is the data is being sent through service bus using Node.js on the cloud, and Node.js allows us to capture data. We have other scenarios as well, so you can connect with mobile services, or you could have done Signal R as well. Signal R is another technology which gives you real-time data connectivity, which you can also use, right? So in this case, the code written is in C++. It's a Linux-based system right now. Linux, especially Debian version of Linux, which is available on this. Code, we could have also used something called Casablanca. Casablanca is something, it's C++ REST-based services which is available, but you need to have a C++ 11 standard following, right? Which means the new system, and that is unfortunately not available on Debian right now. It's available on Ubuntu. So that's why we've chosen to have Node, but it also shows that depending on your choice of language, you can build things, right? Then that connection takes you to the service bus on the cloud, which takes data, put it on a stream inside, Stream Analytics. Stream Analytics fetches the data according to requirement and passes it on to storage. We also connect, we have not done that yet module, that is something called machine learning module. So think about scenarios. For example, it will capture your daily or weekly or monthly scenarios. For example, you buy fruit, you buy grocery on some particular day, or you buy, you have to go to healthcare department certain day. So it will capture all that. All the data is by default captured because the device will be sensing you are going to a food place, you are going to a market, you are going to a supermarket, or you are going to a healthcare department, right? It will capture all of that. We can add machine learning APIs on top of it, and then automatically it will tell you. For example, it will sense the whole, it's a system which we are creating, right? So the device owners will get to know when and where, which route they should choose. First of all. Second, they need to buy a grocery for that matter. They will never forget about it. Like, you will get a notification on top of it. Business part of things, if you are interested in advertisement, the advertisement guide, there's another set of segment, right, who wants to advertise. And if you are interested, it will get, help you connect with each other, right? That's another set of scenario. There are multiple other things which you can do and we are thinking of. So if you have any ideas, you're more than welcome to share as well, right? It's very much possible. Very much possible. So the language and the kind of board we have chosen. Yes, we can definitely go ahead and do that. So the reason why I've chosen this one is the availability part and the cost part. So Galileo, for that matter, is available, but it's more costlier than this one, onto which you can put Windows and then done .NET on top of it, right? So I'll skip with this, more details. I just wanted to share our coordinates. If you have further questions, please feel free to reach out to us. This is the CardNet team, all 4 of them, and this is our coordinate for reaching out. We'll take questions. I'm sorry, we have cut short already on your lunch time. A lot of other sessions are going to come up. So Twitter account, Ujjwal KR and Saurav Kirtani. And for these guys, all of us will be there at the IoT booth. If some of you are joining at Azure night as well, please do so. We have another IoT, lounge out there. So if you're interested to build, we have an architecture solution. We will be helping out with the solution showcase as well. It's a registered based event. So if you're not already registered, there are some, in-person registration also happening. Depending on the availability of people who are coming, we are expected the limited seats, actually 200 seats out there. But we'll be showcasing all these, cool demos of all the services. We have 38 services now on Azure. We'll be showcasing all those services with demos, less slides or no slides, only demos. And then we have do-it-yourself time, wherein will be, we have different lounges. You can go out, talk to us, create your own scenario-based solution. Okay. Thank you with that.